All right, ladies and gentlemen. So, did we come up with for number 2, 2x squared plus 3 times x minus 3? Shh, guys. Shh. Any questions on number 2 for the grouping? And then for the next 4, like I mentioned, guys, don't force it if it's not there. So for number 3, again, when you group, we should end up with x plus 2 times 3x squared minus 2. Again, it doesn't matter the order in which you write the parentheses. So any questions on 3 and 4? Now be careful, guys, in number 5. After you do your grouping, you end up with x squared minus 1 times x minus 5. Go directly. You need to get in the habit of having your eyes focus on the set of parentheses that may have an x to the second power, because that's the set of parentheses that may be able to be factored further. X squared minus 1 is another difference of squares. So you've got to make sure you factor that into x plus 1 times x minus 1. So just be careful, because especially with grouping, you're going to end up with x squares probably in one set of parentheses, and check for that difference of squares. All right? So now the last part is just factoring with all your different trig functions. So take a look at number 1. Which pattern does sine squared minus cosine squared factor into? Is it trinomial? First of all, how many terms do we have? 1, 2, or 4? 2. Is it squares or cubes? Are we dealing with perfect squares or perfect cubes? Perfect squares. So remember, it is a difference. So the way you would factor this would simply be sine of theta plus cosine theta, sine of theta minus cosine theta. So remember, you use the same pattern as you would difference of squares, like an x squared minus y squared. Look at number 2. Cosine to the third is a perfect cube. A tangent to the third is a perfect cube. You've got 2 terms. So what pattern of factoring does number 2 fall into? So it's going to be your cubes. So now remember your SOAP. It starts with the same sign, opposite sign, always positive. I always do my SOAP first. I like to take care of my signs first. Now, what is the cube root of cosine to the third? The cube root of cosine to the third is just going to be a what? It's going to be a what? What's the cube root of cosine to the third? Cosine. Now, cube root of 8 tangent to the third. Well, what's the cube root of 8? The cube root of 8 is 2 times tangent to the third. Tangent theta. So there's your cube root. Square your first cube root. So that's a cosine squared theta. Product. You have to multiply cosine times 2 tangent theta. So it's going to be 2 tangent theta cosine theta. And then you have to square your last cube root. So 2 squared is 4 times tangent squared theta. Should have made my parentheses bigger. Okay? Look at number 3. You have 2 terms. So when you have 2 terms, you're either thinking squares or cubes. Is 4 secant squared a perfect square? Is this a perfect square? Is 9 cotangent squared a perfect square? So just like number 1, you can factor it as a difference of 2 perfect squares. So 2 secant theta minus 3 cotangent theta. 2 secant theta plus 3 cotangent theta. So don't let, because you're seeing those trig functions, scare you off. It's still the same techniques of the factoring that you had for algebra. It's just the bases that are being squared are different. What about number 4? Remember, you always check for what first? You always check for greatest common factors. So you have a sine squared and a tangent, sine to the third and a tangent squared. What's the GCF going to be? How many sines can I factor out of the whole thing? I can factor out what? 2. So my GCF is going to be a sine squared theta. How many tangents are in common with both? How many tangents can I factor out? 1. So my GCF is going to be a sine squared times tangent theta. Remember, when I do GCF, I'm going to divide it out of each term. So what's left over when I divide out a sine squared tangent theta out of the first term? I'm going to be left with a 1. Minus I'm still only dividing out a sine squared, so that's going to leave me with 1 sine of theta. Tangent squared divided by tangent is going to leave me with a tangent theta. So don't forget to always check for those GCFs first. All right? So any questions on that? All right, you guys go ahead and try the next 2 for me.